to help you do technology, or use technology on section 8.5, testing a claim about a standard deviation or variance, mainly standard deviation. And just want to show you the technology we're going to use to do that tomorrow. All right, we're going to do it with the one problem, this problem right here. It says listed below are the heights in inches for the simple random sample of supermodels. Consider the claim the supermodels have heights that have much less variation than the heights of women in the general population. We use a 0.01 significance level to test the claim the supermodels have heights with a standard deviation that is less than 2.6 inches for the population of women. And I gave you a list of the heights of the 10 supermodels right down there, 10 being an important number. Always start out with your ho and ha. It's written down there, which you will need to know. All right, let's pull up the calculator real quick so we can figure out exactly what it is we're gonna find as we find all kinds of stuff. First thing I've done already is I have already punched the numbers in my list one so I can find what I need to find the test stat. You have to find your test statistic first. So I'm gonna go to stat and calc and one var stats. When I go there, L1's good, don't need a frequency list, calculate, and it tells me some stuff I need to know. It tells me the little s is 0.7997, which I'm gonna need that one. My n is 10. I'm gonna need to know what my n is, and that's really all I need to know for this. So I'm gonna go ahead now and do my test stats. So I'm getting out of there. Now the test statistic for standard deviation, you do n minus 1, and n in this problem there were 10 women, so I'm gonna do a 9 times, and you do sample standard deviation squared. The sample standard deviation is 0.7997, squaring that one, divided by the population standard deviation, which is 2.6. Square it. That's the formula for test statistic. We worked on that today in class. Hit enter, and you get 0.851. That is your test stat. 0.8514. That's your test stat, or your chi-square test stat. Now, because we want less than that, I need to find my p-value. To find my p-value, I'm going to go to stat, test. I'm going to go all the way down till I find, whenever you're looking for p's, we've always done CDF. Actually, I'm in the wrong spot. Second var, sorry about that. Second vars, go down, and the number 8 has chi-square CDF. Right, so I'm going to go there. And it's going to ask me my lower, which, we always go, oh, one thing about chi-square, it's always positive, so don't type in negative 1,000. 0 is good. That's what it gives you anyway. Your upper was your test statistic, which I just found out was 0.8514. My degrees of freedom is 9, because there was 10 supermodels. And I'm ready to paste, hit enter, and hit enter again. There's your p-value, which is really 0.00029. All right, 3 zeros, then 29. That's your p-value. Because it is so low, and our significance level on this problem was 0.01, my p is much less than that. You would reject the null, and you would say there's sufficient evidence to support the claim the supermodels have heights less than 2.6 inches, which is less than the general population of women. Their heights differ much less. All right, so really all there is to it. This is one day versus the other days. You do have to find the test statistic instead of just pushing one button and finding it for you. And to find the p-value, you have to do the chi-squared CDF. That's the quickest way to get your p-value, and just trust me there. And I'll see you tomorrow, and we'll work on these in class. See ya then.